Simplifying rational expressions. So now we're going to start taking a look at those rational expressions that we've been looking at, and making them even simpler than we have been looking at. So getting rid of some of those polynomials and those common factors. So a rational expression is an algebraic fraction with a numerator and denominator that are polynomials. So for example, we have x squared plus 1 over y squared. So you'll notice we've got variables in there, algebraic piece, and we have some polynomials going on. So we're going to get back into that, factoring our quadratics. We'll get back looking at that, factoring our polynomials. So we're going to state the excluded values for each rational expression. Remember, the excluded values are values of our variables that will make the denominator equal to 0, since that is highly illegal in math. So we're going to take our denominator, set it equal to 0, and solve. So for our first one, m squared minus 4, 2m over 2m squared minus 8. I'm going to take the 2m squared minus 8, set that equal to 0. Again, looking at this as a polynomial, multiple ways to solve this, so it's up to you to figure out what's the most efficient, best way, knowing the methods that you have to solve this. I decided to add 8 to both sides, then I divided by 2. I came up with m squared equals 4, so I found the square root of both sides, and I came up with positive 2 and negative 2. So if I put either positive 2 or negative 2 in here, I'm going to end up with 0 in my denominator. All right, second one, m squared minus 1 over 2m squared minus m minus 1. I want to set this 2m squared minus m minus 1 equal to 0, which I did. And then I factored that using a product sum here. So I ended up with 2m plus 1 times m minus 1. So again, if I just kind of run that through and make sure that works, 2m times m is 2m squared. 2m times negative 1 is negative 2m, and then positive 1m gives me that negative 1m in the middle there. And negative 1 is positive 1 times negative 1. So yes, those are the factors. I'm going to set each one equal to 0. 2m minus 1, when I solve that, I get m equals negative 1/2. And when I say m minus 1 equals 0, when I solve that, I get m equals 1. So I have two excluded values here, negative 1 and 1. So two excluded values for the second one, only one, 2 also for the first one. They're just opposites in that case. All right, let's take a look at simplifying this. We've looked at the excluded values, so you should be able to state the excluded values. We're going to simplify a rational expression. First, factor the numerator and denominator, then divide each by the greatest common factor. So we're going to be factoring our numerator and denominator, and then figuring out what factors I can simplify out. So a squared plus 3a plus 2 over a squared plus 5a plus 6. So I'm going to factor each of those. My numerator factors into a plus 1 times a plus 2. My denominator factors into a plus 3 times a plus 2. My a plus 2's can cancel out. They are common factors, so I can divide both by itself. And I end up with a plus 1 over a plus 3. So here's the simplified version of this rational expression. And the last one, I have 25 minus x squared over 8x minus 40. So again, I'm going to factor each of those polynomials. I have 5 minus x and 5 plus x in my numerator, and 8 times x minus 5 in my denominator. So I don't have any factors specifically in common, but I do notice that this 5 minus x and this x minus 5 are opposites of each other. If I added them together, I would get 0. So I should be able to take a negative 1 out of one of them, kind of undistribute that, take a negative 1 out to end up with negative 1 times the factor that the other one is. So if I pull a negative 1 out of here, 5 divided by negative 1 gives me negative 5, and negative x divided by negative 1 gives me positive x. So these two multiplied together gives me this particular binomial. But what that does for me, it allows me to simplify out these x minus 5's, since they are now like terms. They are common factors, which leaves me with 8 in my denominator, and I can distribute this negative 1 to kind of clean this up. So I have negative x minus 5 over 8 as a simplified version of this rational expression.